Hi, I'm Gareth Kane, and welcome to the Net Zero Business Podcast. Today, I'm delighted to be joined by Matthew Lumsden, Chief Executive Officer of Connected Energy Limited, to talk about battery energy service systems and Connected Energy's particular approach to them. Welcome to the podcast, Matthew.
Thank you. Good to get to talk to you at last.
And we'll be talking BESS in quite a lot of detail in a minute, but I always like to start by asking guests to introduce themselves by explaining how they first got started in sustainability, or in your case, probably clean energy would be more appropriate.
Yeah. Okay. Well, thanks for that. So, yeah, I got involved in renewables, clean energy about 25 years ago now. So joined a couple of guys who were building businesses, and we bought the Northern Energy Initiative, as it was at the time, which was one of the sort of really early movers in terms of regional energy agencies. So we got involved in that. Then we also bought a research group out of UMIST, one of the Manchester universities. That's now part of the University of Manchester, and they were doing a lot of work on grid analysis. They developed some software called IPSA, which is still used as a market leader in terms of grid analysis. So we bought those two organisations and we put those together and grew a sort of renewables consultancy called TNEI, and largely at the time focusing on onshore wind, PV, looking at grid applications. A lot of work on the planning. Obviously, planning is very contentious around onshore wind. And then my focus, I'm not a particularly technical person, so I spent a lot of time working on strategy type stuff. And it's that got me into the electric vehicle space, working with One Northeast at the time, who were obviously, with having Nissan in the region, were very early movers in looking at vehicle trials, EV charging infrastructure, etc. So got involved in running some trials and some charging infrastructure projects. We sold TNEI. I set up Future Transport Systems. Spent 2 or 3 years running trials, looking at what the future of electric vehicles might look like, and then ultimately really wanted to get involved in developing some technology. And we spent some time looking at vehicle to grid and energy storage using second life batteries. And vehicle to the grid looked very hard from a sort of regulatory perspective as much as anything else. So focused on second life batteries, and can't say that's been particularly easy, but we're still here.
But that's what you do. Right, we'll get on to the whole mechanism of using those second life batteries in a second. But if we could start with BESS itself. If you look at the statistics of the uptake of clean technology, the investment of BESS around the world, even in the US under the current administration, is absolutely huge. So what is a battery energy storage system?
Okay, so a battery energy storage system is kind of what you described. It's a system that stores electrical energy in chemical form, obviously. I mean, lithium ion is the leading technology at the moment. And, that they are of all scales. There's obviously domestic energy storage that people are now starting to install, and there's big incentives in Germany in particular to install domestic. And then there's quite a lot gradually being installed at an industrial commercial scale. And then, there's a massive focus at the moment on really large systems. Yeah. So effectively, in simple terms, I guess the bigger systems are all containerized systems full of batteries, and obviously the power electronics that convert the DC electricity produced from the batteries, convert that in AC and connects into the grid. And there's been a lot of, and still is, an awful lot of evolution. Obviously, the chemistry has typically been lithium ion based to date. But new chemistries are starting to come into play, but there's an awful lot of progress now in terms of improved energy density, improved efficiency, and then also in terms of the longevity of the cells. They're really reducing the degradation levels. So these are long-term assets, and now really critical in terms of making the new electrical infrastructure operate effectively.
Yeah. So at say, let's take an organizational level, that sort of in between level
Mm.
you were talking about there. What would be the purpose of a BESS installation for a large manufacturer, say?
Okay, so I guess you've probably got three applications. Some people install systems on their sites purely to generate revenue.
Hmm.
Effectively, what happens is you charge and discharge your system to provide flexibility into the grid, and you get paid for that service. So you could just generate pure revenue by having a containerized energy storage system on your site. Then one of the other typical applications is around sort of energy system optimization. So if you've got a number of different assets on your site, so you may have PV, you may have ground source heat, air source heat, you may have EV chargers. So you can save costs, or and those might be financial costs, or they might be carbon costs, by starting to change the load of your site in relation to the production of PV or the load, say, produced by the EV charging infrastructure. So you may be in a situation where at some times of the day you're exporting your PV. So instead of exporting it, you can put it into your energy storage system, then potentially use that to charge your EV chargers. So it's around overall site optimization, and a few people looking at that from a commercial, but also from a carbon impact perspective.
Yeah. So you're basically time
Um,
shifting energy, for want of a better word.
your time shifting energy. So if that's your energy profile, typically what you're trying to do is flatten it. And then I guess the third application is problem solving. I guess a very typical application for that is in relation to EV chargers. So as the power of EV chargers increases, they put a big load on the grid, on your connection, and quite often people don't have the capacity to provide the amount of power that the charger might require. So quite often you can link that with energy storage, so that you pull some of the power from the grid and some of the power from the storage system. And as loads increase, a lot of people are being constrained by their connections, and it takes a long time to upgrade your connections, and it can be very expensive. So storage can either be a temporary or a long-term solution. And you have situations where if somebody's looking to adopt electric trucks, for example, typically they'll install quite high power chargers. And if they want to trial some vehicles, then quite often they will install storage alongside the charger, so that at least they've got a temporary solution so they can trial the vehicles, get to use them, decide to use them. If they decide to go for that on a permanent basis, they can make the expenditure on a permanent grid connection.
Yeah. So you're basically charging the battery slowly and then discharging it quickly in order to charge other batteries.
You're doing that, or you're charging the battery at a time when the load is less, so you can potentially charge it rapidly. But if the load on the connection is relatively low, then you've got more capacity to charge the battery. So it's shaving off those peaks in your demand, so that the connection capacity can cope.
Yeah, because one of the fascinating things that I hadn't realized until recently is that the peak power is extremely expensive and very carbon intensive, because even if you're using a gas-fired power station, the efficient combined cycle gas turbines don't like being switched on and off quickly, and peaker plants are much more carbon intensive. So it almost boggles my mind then, all the different combinations of supply and demand that you could be working on.
Yeah, and you've got to, obviously, the grid operator has a big challenge. That they're responsible for balancing that load and supply. And as we get renewables on the grid, increasing penetration of renewables, we get less predictable weather. Then that balancing model is increasingly challenging, and that's where storage starts to play its role.
Mm-hmm. So the grid connected versions, what is the business model? do you typically get paid for just having the capacity there ready to go on standby, or is it when you dispatch the power onto the grid?
So, yes, I mean there's a revenue stack, if you like, and that varies according to different countries. But some of that revenue is so ultimately what you're trying to do is help manage the disparity between the supply and demand on the grid. And part of that, part of the revenue stack is to provide really short, sharp bursts of charge and discharge to help manage the frequency of the grid. Then there's other components which are around managing more around managing the energy.
Mm-hmm.
And there's other parts that are to do with actually trading energy. So you can trade, it's an arbitrage type model where you'll buy energy when it's cheap and discharge it back into the grid when it's more expensive. So to make a robust business case out of energy storage, you have to feed into a range of these different revenue models in order to make it pay. And one of the challenges is that the revenue around energy storage is very much dependent on the other assets in the mix.
Mm-hmm.
So as the penetration of renewables or even the balance of PV and wind changes, then that changes the requirement for the services provided by energy storage. So you tend to go through a phase where as the energy storage market matures, you tend to go through different phases where different types of services are required to manage that balancing of the grid.
And is that process automated? Does the grid operator basically flick a switch or algorithm driven?
National Grid provides signals, and then you get organisations that are often termed aggregators, or they might be a function within a utility. They have a trading strategy, and then effectively you'll typically hand your asset over to one of these third parties, and they will charge and discharge the system to generate the revenue. And typically what they'll do, certainly if you're a utility, you'll bundle that energy storage system in your overall asset mix. So ultimately, you're sort of playing to a number of different revenue models, if you like.
Yeah. And am I right in saying that BESS generally operates over quite a short time frame, hours rather than days for a grid connected system?
Yes. So I mean, again, as the energy storage market matures, what typically happens, again, there are geographical variations. But if you look in the UK, when the energy storage market first started, you were looking at systems which typically were 1 hour systems. So 1 megawatt of 1 megawatt hour, and then that configuration gradually evolves. So it's been through a period where it's sort of 2 hours, 3 hours, 4 hours. In the US, all the systems are longer duration. So and I think typically where the model is evolving is to incorporate more and more long duration systems within the mix, so that you can trade for operate over a period of perhaps 8 hours and even longer. People are looking at new technologies to test the viability for potentially 12-hour duration.
And is that battery chemistry that determines that, or is it?
Well, at the moment, because lithium-ion is staying so cheap, it is still the prevailing technology. But there are other technologies being explored that perhaps are a better economic model for some of these different cycle times. So there's an application there for things like flywheels for very high power over very short duration, and then you have flow batteries, which don't seem to have got much traction yet, but a very long cycle. But lithium-ion obviously started in the middle there, but because of the cost, it's still being deployed for much longer duration systems as well.
Yeah. We seem to be living in the age of lithium. If it's
At the moment,
vehicle storage or laptops, phones, everything.
everywhere.
None of it would work without the lithium-ion battery, would it?
Very troubling in that you have wasted, totally unnecessary batteries all over the place at the moment, and obviously they cause a constant problem in the the disposal side and the
Yeah.
pollution side, etc.
Well, I did. Oh, I can't remember the numbers, so I shouldn't really go down this line. I did do some calculation on how many disposable vape batteries it would take to put to power an EV, and it was a lot. It was so. I'm not. I think the fire hazards is probably maybe a bigger issue than the lithium, but
Yeah,
obviously it would be good to recover it all or ban the
yeah. I
things.
mean,
So
refuse disposal companies are having hundreds of fires a year
yeah.
caused by things like vapes.
Yeah, yeah. If you want to get a waste manager to go puce, uh,
Yeah,
mention disposable vapes, which takes us on to the fire safety things. Like every clean technology, there's this sort of there's always somebody trying to do it down and make criticisms. And fire safety is the issue they keep raising about battery systems. So what is the reality about the risk of fire in a BESS system?
I mean, I guess the reality is that fires are happening. I think there is still a lot of work that needs to be done on some of the control systems to help manage that better. I think at the moment the challenge is that a lithium-ion system is very difficult to suppress the fire. So the strategy is typically to let it burn, but obviously evacuate the area and let it go down that route. But the technology is evolving, the fires are reducing. I think we're learning about the causes.
Mhm.
And that's not necessarily always a problem with the lithium ion that's causing the initiation of the event. So yeah, I mean it's obviously unfortunate, but it seems to be improving in terms of the frequency with which it happens. And obviously, every time there is one, it gets a hell of a lot of airtime, as does a fire in an electric vehicle. It's
Yeah.
totally disproportionate to the number of times it actually occurs.
Or a fire in an internal combustion engine vehicle that everybody says is an electric vehicle but isn't. Uh,
Well, exactly.
yeah,
Yeah, yeah, yeah.
yeah. That's it. And the other interesting thing, I suppose, getting quite nerdy, was that you were talking about frequency balancing as well, because the big Iberian power shutdown in last year, April last year, was blamed on parts of the grid get their frequencies getting out of sync, so sudden
Yeah,
get sudden
yeah.
surges in current. So, what role does battery storage play in
Yeah,
sorting that out?
and obviously, increasingly, there's a requirement for resilience, or a perceived requirement for resilience, and part of the new requirements of energy storage systems in a number of markets is a requirement that the systems can provide a black start.
Yeah,
I.e., if the grid's gone down, then the storage systems can kick it off again. And you had assets. So an example would be Linemouth Power Station up in the northeast of England. Used to power the smelter,
yeah,
but that also had an incredibly lucrative contract to provide a black start in case the grid came down, and that the generator in there could be used to kick it off again. So this is becoming an increasingly important component of the role that large scale energy storage can play in the sort of, I guess, the evolving operation of the grid.
yeah. It seems to be a bit of a challenge because the traditional fossil fuel power stations have literally spinning parts that keep some
Yeah,
inertia momentum going. And again, I'm stretching at the edges of my knowledge of the subject, but as I understand it, is a little bit more of a challenge to do this with a battery system than with a turbine that is still turning because it had been turning before.
Well, I mean, I think the key thing is response time and coordination. So, the challenge is you've obviously got far more assets. Yeah, how do you actually manage to coordinate those assets effectively and bring them on in a controlled way?
Yeah. And in Spain, it seemed quite uncontrolled. Uh,
Yes.
moving on then to what you do at Connected Energy. How did the whole idea of using EV batteries come about?
So I guess it was one of the instances that I talked about earlier. We were looking at installing, when we were working on charging infrastructure projects, we were looking at installing some of the very early installations, and we were coming up against grid constraints all the time. And a lot of the guys I was working with were also involved in the early electric vehicles, and not quite sure how it came about, but we looked at the project at Lotus in Norfolk, which looked at installing Second Life batteries to manage the grid load on some charging infrastructure there.
Mm.
And I think you've only got to follow through the logic to say batteries degrade. At some point, they'll be too degraded to enable somebody to drive their vehicle the range they would like to, and therefore they either get recycled straight away or they get reused. And typically what happens is that there's potentially 30-50% of the capacity still available in the battery before it's recycled. I guess what we've learned and what the industry's learned is actually the batteries degrade at a far lower rate than everybody expected. I guess the expectations a few years ago that batteries were going to last possibly 7 years, and now really they last 15 years.
Yeah.
So they're taking a lot longer to come through, but that, by the same token, that demonstrates the quality of the batteries that are being used in the vehicles and that we're using in the systems.
And the average car life is 13 years. So,
right, okay.
Yeah, so it sounds like, again, one of these myths that bounce about on the internet seems to be, oh, you'll have to replace the expensive battery after a few years, but it sounds like you probably replace the car before you replace the battery.
Yeah, exactly. I think the whole vehicle comes to the end of its life. I mean, there are some applications. So I was with somebody earlier in the week who was saying that the Teslas that are being used for taxis, are doing so many miles and being charged so frequently that their batteries are degrading and they're looking for replacement batteries. But that's a really high use application with really aggressive charging, which obviously accelerates the degradation. But typically most people are not going to need to replace their battery within the lifetime of the vehicle. Certainly, personal vehicle owners.
So, at what level do you take the batteries for your systems?
So it varies. I mean, one of the things we've learned is that batteries are all sorts of different shapes and sizes. The energy density has evolved enormously, and therefore some batteries just aren't viable to reuse. If you look at something like a Tesla pack, or if you look at all the packs that are used in buses and trucks, they are really regular shapes that you can really stack effectively within a container, so you can get really good energy density. So we will typically look for those kind of packs, and I guess we're tending to find that they are somewhere between perhaps 5 and 20% degraded.
Yeah.
And typically they're less degraded. So, up towards the, maybe 10-15% degraded rather than going right down to 20. So we're in a position where we can choose batteries that are less degraded, and they obviously give us a much better energy density and much better economics of the system.
And are there enough around, given that, EV uptake is starting to surge now, but you must be taking the first movers batteries, really?
Yeah, so we're to build the business, we found that there just aren't enough of one type of battery. So we have to work with a number of different suppliers. And the architecture of our system is such that, I mean, we have a central power control system, and then behind those we have container loads of batteries, and we can put a different type of battery into each container. So what that means is that we can source batteries from a number of different sources and build up the kind of volumes we're targeting. So it's an early mover challenge, which as soon as the volumes really start to build up should disappear, and it's probably best just to focus on one or two different types of pack.
Yeah. Yeah, and you'll get a more consistent supply, presumably, then just by
Yeah, and I think that's what we're now starting to find, is that there are just enough packs starting to come through for that to be of a material interest to either fleets that are looking to repower, or disassemblers, or vehicle or battery OEMs. So volumes are just starting to become sensible, where they start to look at the business model and really start to focus on how to make it work.
Yeah. And then perhaps this is delving too far into company secrets, but is that, do you have to pay for the second life battery, or is it or do you have a gate fee, or when things are end of life, they can be positive value, negative value. It varies a lot.
So the answer is it varies. I mean, the good thing from our perspective is that because the volume is increasing, the price of the batteries is reducing dramatically. Now we're moving into a model where we're looking at much larger systems. When we were looking at small systems, we were buying the batteries and reselling them as part of the systems, whereas the much larger systems we're working on now are looking at a model which is, I guess, much more akin to something like an energy from waste plant or an AD plant. Where effectively we have the front end, the power electronics, which is the facility, and then the batteries go into the facility. We cycle them for a number of years, we generate revenue, and we feed that revenue back, or part of that revenue back, to the organization that owns the batteries. And typically a third party owns the batteries, so that they can then also benefit from the upside of the recycling further down the line. So, certainly if you look at the OEMs, they're really trying to maximize the value in the battery all the way through the value chain, because I guess the business model around e-mobility is so lean. And they're losing a lot of the other revenues that they would have previously got from ICE vehicles.
Yeah, like selling spare parts and things like that.
Spare parts, service and maintenance. I mean, it's all much, much lighter than it was with ICE vehicles.
Yeah. I think that's one of the real challenges on the legacy developers moving into the EV space, is that the business model, the through life business model, is quite different. So how long typically then does I know you're going to say it depends on how many times you discharge it and how rapidly, but typically how long would you expect a battery, once it's out of the vehicle and into a system such as yours, before it comes to the final end of its life?
So I think, if you look at the sort of degradation curve of many of the batteries we're looking at, and the level of degradation we receive them at, then excuse me, we tend to model a battery change at about 8 years. However, my sort of working hypothesis is that actually the cost of the batteries will reduce dramatically. And actually the value in the system is linked to the amount of capacity you've got in the system. So I think you'll get to a point where actually it makes sense to change the batteries earlier, so that you can increase the capacity in the system and get more revenue. And then when you change the batteries, you obviously then get the value from recycling. So I think, it comes back to this energy from waste kind of analogy, where you just feed the batteries in, you run the equation from time to time to say, well, what's the best thing to do now? Is it best to keep them in the system, or to pass them on to recycling and put some more batteries in the system? So looking at it, it's a very different model to a normal energy storage model.
Yeah, and one of the things I'm taking from this because you've implied it several times, is that the battery still has a positive value once it's done, which again goes against some of the myths
Well,
online that we're going to have this
that's
stack
that's
of
the
batteries in.
expectation. That's the expectation, and I think we're hearing mixed stories, but I think the prevailing messaging we're getting at the moment is that they are more or less cost neutral, potentially have a slightly positive value already,
Yeah,
and that depends a lot on where you recycle them. But we're definitely moving into a more positive downstream value, which is why people are wanting to retain ownership of the batteries all the way through their lifespan.
yeah, very interesting. So, in terms of the use cases, what's your best line? Who's your best or best market, I suppose,
So
the systems?
I mean, our conclusion is that to make Second Life work, you've really got to move into much larger systems.
Yeah.
So we've moved away from, and we still do some larger behind the meter systems on industrial and commercial sites, but typically we're now moving over towards standalone systems just connected into the grid. Our business model really is about saying to somebody with batteries that we have the enabling technology and also we can guarantee a route to market for those batteries.
Hmm.
So we're also developing projects so that we can guarantee there's a site there. We can design the site around the battery flow, and then as soon as the batteries become available, we can feed the battery straight into projects. So we're trying to reduce as much of the cost of logistics, the cost of handling, out of the equation, so that effectively, as soon as the batteries come out of a fleet of buses, say they go straight into an energy storage system and start generating revenue.
Yeah.
So, and the challenge of our business has been joining all of that lot up across the value chain, and you're dealing with big players, and you're also dealing with the automotive sector and the energy sector, and there's a lot of new territory there. It wasn't really about building a business; it was about trying to build a new type of sector, really.
Yeah, well, I suppose if you went back a decade or two, we met when you were at TNEI, that you mentioned in your introduction. If we went back then and said that, there was a business in taking EV batteries and connecting them to the grid, I think a lot of people would have scratched their heads. So it's
Well,
all cutting
true,
new
but we
ground.
were doing the same with wind turbines then. We were taking repowered wind turbines and installing them on industrial commercial sites then as well. But the wind turbine technology has evolved so much I'm not involved in it anymore, but I'm not sure that that's viable anymore.
Right. So some of these opportunities may come and go and become redundant. So what's next? What's the next big thing, do you think?
I mean, the next big thing from our perspective is scale up. So we've got a project development team in France now.
Yeah.
So we're originating sites in France. We're in the process of locking down some big battery supply contracts. And I guess connected energy is moving from a phase which was probably quite a heavy focus on R&D,
Yeah.
integration and testing the systems and making sure they comply with the associated requirements. Now really focusing on deployment. So I think we've got about 30 systems operational, providing all the kind of services that we talked about earlier. We've proven the functionality. We've got enormous amounts of data showing how the batteries behave. So the next thing is to move into really starting to, as I described, take the batteries straight out of vehicles and deploy them in projects. And our target is to have a gigawatt hour either in build or in operation in 2030.
Yeah. You mentioned data. I suppose we should have asked this question before. Well, I suppose we touched on it on the trading and the dispatch and particularly with the grid, but it struck me that Octopus Energy, the massive breakthrough energy business here in the UK, they saw themselves originally as a data company rather than an energy company. Uh, you know, is data, or how important is data in all of this process?
I mean, certainly from our perspective, it's critical because, I mean, the advantage of second life batteries, this might be slightly counterintuitive, but, they, they are probably the safest. Well, automotive batteries are probably the safest batteries
Yeah,
because they're the top grade of cells and they have all the safety systems that are required to, sit your family on top of them and drive them down the motorway.
yeah,
And then if you think on a typical failure curve, you kind of have a bath curve where you get failures at the beginning and failures at the ends, and we're using that central piece. But by the same token, we are still absolutely focused on safety. So we want to demonstrate that safety. We want to demonstrate that the batteries are doing what we tell our customers that we're doing. We've obviously got to insure and finance the system, so that data is absolutely critical to that. We want to maintain the uptime of the system, so again, we can use the data to do preemptive maintenance. But then the other thing about our systems is that if you imagine there's 1,000 batteries in a system, even if those batteries are the same type of battery, every single battery will be slightly different in terms of its state of health. So, the way we use data is to pull all the real-time data out of the battery and optimize the way we use those batteries individually. So data is actually key to that, to optimizing the value we can get out of the batteries before we pass them on into a recycling application. So, I think part of the IP in connected energy is really, I mean, it's like a jigsaw, except all of the pieces of the jigsaw change shape all the time. It's about how do you put all those pieces together and get the best value. And, all of that is driven by data.
yeah. That's fascinating. It does sound both very exciting and in some ways a bit of a nightmare because, as you say, the the pieces just, I suppose the whole area of clean energy is moving so quickly. And, particularly with some of the geopolitical things going on in the world, I think there's going to be around the world this massive uptake. We've already seen Pakistan install, was it in 1 year they installed more renewables than their entire grid capacity.
Right. Yeah.
Just
Yeah.
in a single year, India has suddenly decided that maybe coal isn't and fossil fuels aren't quite so good, and massive investment there as well. So I can only see this sector expanding rapidly.
I think the exciting thing though is that there. I mean, I still think it's a bit light touch, but I still think that there's been quite an escalation really in focus on the circular economy.
Yeah,
And I think, I remember going to talk to a funder once who told me that, the difficult bit for the circular economy is reuse because, you're using something for a purpose for which it wasn't originally designed.
yeah,
So therefore, there will always be some compromises. So I think, this focus on the circular economy and maximizing the value you can extract from everything, and importantly, within the market, within the locality that it was originally placed, is gaining a lot of focus and is really important. And it feels like a critical part to sort of national security in terms of energy, in terms of security of materials. But then also, it's obviously got a significant reduction in environmental impact if you're extracting less metal or other materials.
yeah. Well, it's just I read the other day somebody describing an EV as basically a battery with a couple of motors and things and seats connected to it,
Yeah,
but it's basically a battery. And this almost expands that idea that instead of being a car manufacturer, you're basically the battery is the product. If people are maintaining the ownership of that, through Second
yeah,
Life and then through to recycling as well. So it's quite a
yeah.
different
And
way of thinking about things.
if you think of an EV as a mobile distributed energy storage system, I'm convinced that vehicle to grid will also be a massive part of the system design in the future.
Yeah. Well, we had Colin Heron, Professor Colin Heron, on
All right.
was it 2 years ago? He was skeptical about vehicle to grid on the scale. He said possibly if you had a an airport car park, ironically, if you could have lots of cars sat doing nothing for days, then you might get a viable business model. But on the other hand, we had Octopus Energy on, who said they're already doing an element of vehicle to grid
Exactly.
to support, I think it was particularly rural
Yeah. Yeah.
energy supply, where the quality of the transmission may vary, and
Yeah.
they were already connecting vehicles to their grid to help support that as well. So
Yeah. Yeah.
probably business models we'd never thought of before will emerge.
Well, exactly. I mean, you think Nissan originally developed it for vehicle to home to provide resilience after one of the, I think, earthquakes they had. So,
Yeah.
it provides an emergency service as much as anything else, potentially.
Yeah. Well, as I said before, I think we're definitely living in the lithium age. Right. Well, I find that fascinating. I know more than I did when we started, which is always my quality test of these discussions. So it just leaves me to thank you today for joining us today, Matthew,
Yeah. Thank you.
and all the best for the future.
Thank you. Good to see you again. All the best.